All right, guys, final lesson this week. You made it, lesson 104. So semicircles, arcs, and sectors. This one's going to be all about good old circles, okay? So we're going to be talking about, we are going to review area and circumference, and then we're going to be looking at how we can use those measurements that we already know to help us find arcs and sectors, okay? So let's go ahead and start. We're going to dive right in on this one. I'm going to start by reminding you of your formulas, okay? So let me just give us a couple of circles here real quick. All right, so circumference of a circle, circumference, let's spell that together. That's a fun one, huh? Circumference, there we go. Circumference, remember, measures the distance around the outside of a circle. So circumference is talking about this distance all the way around the outside, okay? Area, just like any other shape, area is always talking about the inside of a shape. Ooh, just kidding. Wrong thing. Okay, the area is always talking about the space that's taken up on the inside. So let's review those formulas. Circumference is always going to be pi times the diameter. Area is always going to be pi times the radius squared. Okay, and I know you guys know this, but let's just review it real quick anyway. The diameter, remember, it goes through the center of the circle all the way across. The radius starts at the center and just goes out to one point on the outside. So the radius is actually half of the diameter. Okay, just a little quick review there because that's what we're going to need going into the next section here. All right, so let's look at this lovely little figure that I've created here. This is actually also in your book on page 104. Theirs looks a little bit better than mine. I just kind of had to freehand it with the tools that I have on here. Actually, I mean, if I'm not trying to toot my own horn, but it's not too bad if I do say so myself. So we've got, if you notice, this is what we call a composite figure, okay? It's a composite figure because it is the joining together of two separate figures. So we see over here on this side, we've got a semicircle, which again, remember, a semicircle is half of a circle, okay? Semicircle is going to be, it's not making dots to save my life. It's like I want to dot my eyes. Just dot my eyes. Okay, there we go. Semicircle is half of a circle, okay? And then on this side, we've got a rectangle. Okay, so it's a joining together of a semicircle and a rectangle. So the first question asks us to find the perimeter. So if we want to find the perimeter, finding the perimeter of a rectangle is easy. You just add up all the sides. Perimeter of a circle we just talked about is actually called the circumference. Very good. Which we know circumference of a circle is pi times the diameter. Now, are we seeing a full circle here? No, we're only seeing half. So if you were thinking, which I know you were, oh, shouldn't we divide that by 2? Oh my goodness, you're so smart. That's exactly right. We're going to take pi times the diameter and divide it by 2. That will give us the circumference of this semicircle or half of a circle here, okay? So let's go ahead and do that. So we know that our radius is 5. So if our radius is 5, our diameter has to be 10. So we've got 10 pi divided by 2. I'm going to show you what this looks like to keep it in terms of pi, just real quick, and then we'll change it. If your answer or if your question said keep it in terms of pi, what it means is don't actually multiply by pi here. So really all you'd have to do is divide the 10 by 2, which would just give you 5 pi. Okay, so we're going to keep it in terms of pi for just a second while we jump over here and we look at the the perimeter of the rectangle. Now, is the whole rectangle on the outside? No, because we see this side, and this side are exposed to the outside, and that's it. And you might be thinking, well, they gave me this one up here is 4, so that means this one down here has to be 4, but what about this long piece over here on the right? Well, notice that it matches up with this piece right here, which although it's not in a part of the outside, We do know that it lines up with the diameter of our circle. So if the radius is 5, we just talked about the fact that our diameter would be 10. So if this whole diameter right here is 10, then this side over here also has to be 10. Okay, so we are just looking at adding for the rectangle portion of this figure, adding the 4, the 10, and the 4, which would give me 18. Now I'm going to jump back over here real quick to this 5 pi, and I'm going to go ahead and multiply that, which would end up giving me 15.7 approximately. So that's rounded a little bit, okay? So then when I add that to my 18, that should end up giving me 33.7 units. Now, do we need to square it? Correct, no, because it is not area, it is just perimeter. So perimeter does not need to be squared. I think a couple of you missed some points on the last test for that one. So just remember, you don't need to square the perimeter. You do need to square the area. Good, awesome. Okay, so now I'm going to bring that exact same picture back up from scratch, and we are going to find the area of it. So area is a different formula, if you remember. So the area of a circle is pi r squared, but just like for a semicircle, we had to split the circumference in two because only half of the outside was being shown. Only half of the inside makes up the area here. So we also need to divide our area by 2, okay? Because again, this is only half of a circle, not a whole circle. So we're going to multiply pi times radius, which is 5 squared, over 2, okay? So then when I multiply all that out, I'm going to end up with approximately 39.25 meters squared. Now, we already determined this outside piece, and so it would remain the same. It's still going to be 10, like what we said before, because of the diameter, right? Okay, so for area of a rectangle, now the whole perimeter of the rectangle wasn't part of my shape, but now the area of that whole rectangle is part of my shape. So I'm finding the whole area of a rectangle, which is length times width or base times height, same thing. So that's going to be 10 times 4, which I know is 40. So now all I have to do is combine these two, which would give me approximately 79.25 meters squared. Awesome. Okay, moving on. So let's look at this lovely little guy. So this says to find the area of the shaded sector of this circle. Okay, and I forgot to shade it. So let me just shade that real quick so that that'll make a little bit more sense. We want to find the area of this section right here. Okay, kind of looks like a Christmas tree in April. Okay, so to find the area, we've already talked about area of a circle being pi r squared. If nothing else, you guys should know these formulas by the end of this because we're just going to keep repeating them. So pi r squared is the area of a circle, but we are not talking about the whole circle here. We're only talking about this section. So then the question should be, okay, well, if I know this whole piece out here, they're showing me this whole piece. Oops, excuse me. Oh no, how did I move that? Okay, hold on. Oh gosh, now I'm moving the whole thing. I don't know what I'm doing. Sorry, guys. Okay, so we know what the question says. So if I know that this whole piece out here, what I was trying to do was show you this whole section out here is 300 degrees, then that means my little piece of the pie, a whole circle 360, so my little piece of the pie has to be 60 degrees, okay? So out of 360, 60 out of 360, if you simplify that, actually represents 1/6, okay, of my circle. So I could just take my pi r squared and divide it by 6. So I'm going to find the area of the whole circle, but then I'm going to divide it by 6 to give me just that 6th section of it, which is what that represents. Okay, and again, that's based on the fact that I know the angle measurement of the whole circle is always 360 degrees. So let's plug in what else we know. So we know pi times the radius is 6, so 6 squared divided by 6. So that's going to end up giving me Let me flip to where I can see the numbers because I'm not actually calculating it right now, just to save us a little bit of time. All right, so that, when you multiply that out, should give you, and you're using 3.14 for pi here, okay, should give you approximately 18.84 centimeters squared. Okay, let's look at another one. Okay, so when we've got a figure that looks like this, okay, and we're told that in this figure, central angle AOC, so we're talking about this angle right here, measures 70 degrees. What is the measure of major arc ADC? So let's talk for just a second about major arcs and minor arcs. A major arc is always going to be the arc that is greater than 180, because 180 is half. So a major arc is going to be more than half of the outside of the circle. So greater than 180 is going to be a major arc, okay? A minor arc would be less than 180. So AC would be the minor arc. ADC is going to be the major arc, okay, if everybody sees that. All right, so to find the measure of an arc, okay, an arc in degrees is just going to be whatever the central angle is, okay? So it's the same as the central angle. So in this one, then, we know that the minor arc is going to be the same as the central. So the minor arc is 70. Well, if I know the whole thing is 360, I can just take that 70 degrees and subtract it from 360, which would then give me 290 degrees. So that then, I don't know why that's not showing up. Oh. So 290 would be the measure of my major arc. Okay? Now, sometimes they are going to give us an arc that has a radius value. So let's pull that up so you guys can see what this looks like. We're almost done. I know this is kind of getting to be a longer one. Okay, so sometimes they're going to give us an arc that has a radius value here. So we know this arc has a radius of 2, and it's centered at the origin. Okay, what is the length of the arc? So we know the radius is 2. So we know that the full circle, if it went all the way around, would be 360. Okay, so we are talking about circumference here because the measurement of an arc is actually the outside part. Sector was part of the area, remember. Arc is part of the circumference, okay? So an arc would be circumference, which is pi times the diameter. But then here, notice that this is actually forming a 90-degree angle, and we know that in a 360 degrees, there are 4 of those. So this is actually just going to be 1/4 of my circumference of the whole circle, okay? So I'm going to do pi times the diameter, which I knew my radius was 2. So my diameter has to be 4 divided by 4, which, oh, look at that. Those guys can cancel. That's always fun. So then my circumference, or my arc here, is going to be approximately 3.14 units. Not squared because it's circumference, which is actually like a perimeter. All right, so let's just review real quick. We started out by talking about circumference and area. Make sure you know those formulas. If you don't know those, you're going to struggle in this lesson. Then we looked at the composite figure and how we could find just the semicircle circumference and then the perimeter of the rest of the rectangle. We looked at how to find the area of a semicircle. So remember, for both of those, we just used the regular formula, but then we divided by 2 because a semicircle is half of a full circle, okay? Then we looked at sector. Remember, sector is just part of an area of a circle. So you're just taking area formula and dividing by whatever portion of the circle that sector represents, okay? Same thing with this, with the arc. It's just part of the circumference. So you're just taking the circumference and then dividing by whatever portion of the circle that arc represents, okay? I know you guys got this. Go practice it, and I can't wait to see you again next week. Have a great week, guys. Bye.